Exact values. There are certain exact values you must just learn. Let's show you how we get at these. Here we have a right-angled triangle with shorter sides 1 and 1, which means it's an isosceles right-angled triangle. Using Pythagoras' theorem, the hypotenuse would be root 2 in length. Both angles are 45, so it doesn't matter which angle I refer to because they're both the same. So I'm just going to refer to this one. So sine 45 is the opposite over the hypotenuse, so that's 1 over root 2. If we rationalize the denominator, that's root 2 over 2. Cos 45 is adjacent over hypotenuse, which is 1 over root 2. And of course, in the same way, that's root 2 over 2. So sine 45 is equal to cos 45. Tan 45 would be opposite over adjacent, so 1 divided by 1 is 1. Now consider another triangle. This time we have an equilateral triangle. And we're going to split it in half like so. If we say the length of the sides of the original triangle were 2, that means this length here is 1. This is 60 degrees because it's one of the angles of the original equilateral triangle. This is 30 degrees because we cut this angle in half. And of course it's right-angled here. Using Pythagoras' theorem, this side would be root 3 in length. So that's the square root of 4 take away 1. So if we look at sine 30 degrees, opposite over hypotenuse is a half. Cos 30 degrees, adjacent over hypotenuse, is root 3 over 2. And tan 30 degrees is opposite over adjacent, that's 1 over root 3, which rationalizes to root 3 over 3. Sine 60 is opposite over hypotenuse, root 3 over 2. Cos 60 is adjacent over hypotenuse, so that's a half. And tan 60 is root 3 over 1, which is just root 3. We can summarize these in a table. So we've got 0, 30, 45, 60 and 90, sine, cos and tan. And the 30, 45 and 60 are what we found just earlier in this lesson. So the sine of 0 degrees is 0. The cosine of 0 degrees is 1. The tan of 0 degrees is 0. Now we just found sine 30 is a half, cos 30 is root 3 over 2, tan 30 is root 3 over 3, or 1 over root 3. Sine 45 and cos 45 are equal at root 2 over 2, or 1 over root 2 if we haven't rationalized. And tan 45 is 1. Sine 60 is root 3 over 2. Cos 60 is a half. Tan 60 is root 3. Sine of 90 degrees is 1. Cos of 90 degrees is 0. And the tan of 90 degrees is undefined. Don't worry about that just for the moment. Now, using these values and the cast diagram, we can find the exact values of many angles between 0 and 360. In fact, any multiples of 45 and 30 can be found. And we can go beyond 360 if we need to. Now note there are some symmetries in the table that help you learn them. For example, look at the values for the sine. The values for the cosine just run backwards. It's really important that you know these exact values, because occasionally trigonometry does come up on a non-calculator section. And also, you can really speed things up if you recognize these values rather than having to calculate them.